We are starting, yes?
As you
yes,
say, yes.
Yes.
Anatoly Pavlovich is ready, as I understand. Anatoly
Professor
Pavlovich was
Rykov
the
is
first.
here.
Yes, Professor
So-
Rykov is
So
here.
a few words about our history, because Mohammed maybe don't know everything, yes? So we are at the facilities of the People's Friendship University of Russia, you know, Rudny University. It's so-called big seminar or multi-university seminar. We have 5 founders, yes? Yes, Rudn, Tomsk State University, Moscow
Now
University
even
of
6.
Telecommunications, what else? Russian Academy of
Russian Academy of
Sciences.
Sciences,
Two,
yes.
two institutes, we say institute. Yes, so, and our tradition is to hold the seminar once per month, at least, yes. And usually we give the chair to some people who are preparing their dissertations at PhD level or at doctor level. You know our system, yes.
Yeah.
And this time, first of all, I would like to thank you very much to Amar. He organized this session of our seminar, and I'm very happy to see here Professor Mohammad Hammoudeh. Yes, I don't know the spelling maybe exactly. Thank you very much. Yes, and I say a few words about him. First of all, I remember, and he remembers me personally when he was here in Moscow. And he is professor. He is chair of cybersecurity in the Department of Computing and Mathematics at the Manchester Metropolitan University. He also heads the Internet of Things Lab, yes, which you founded yourself maybe 5 years ago, yes?
Yes.
So he is very experienced in the area of cybersecurity. I'll say a few words about this thing, why this area is very important for us. Of course, he is very known and recognizable scientist. Please, you can say a few words about you, and please introduce yourself. And I do hope that we will continue our contacts after these seminars. And I should say a few words why it is so important for us today. First of all, of course, 2 days ago, 2 presidents speak a lot about cybersecurity worldwide. Yes, so that is the first position. So it isn't doubt why the area is of great relevance today. And for us in our university, it's very relevant because maybe 3 months ago, my rector urged me to open a new study line at the mathematical department, because you know you are from the point of view of Rudn University at the mathematical department. First, we have mathematics, the Institute of Applied Mathematics and Communication Technologies. I'm head of this institute, and this institute has, first of all, of course, teaching on learning study lines, and of course research, both. We are not so skilled in research in the area, but we are very interested in the cybersecurity as from the point of view of our perspective. So please, maybe you will have not so much questions regarding the content, yes, because I'm not sure that there are a lot of experts here, but we are very grateful to you for your introduction in very modern area today as a worldwide expert. So the floor is yours. Please introduce yourself. Feel free here, and I do hope that we will overcome everything and we will meet you in Moscow sometime, physically we say, yes?
Yeah,
so please, so. Professor Mohammad Hammoudeh, please.
Thank you so much for the nice introduction, and thank you so much for the invitation. It's a great honor to be presenting to such multidisciplinary crowd. Of course, Russia is known to be a cybersecurity leader, and it will be a great pleasure to continue to work with you. I am currently intensively working with Ammar and his team, and it will be a great pleasure if I continue and expand this collaboration with the rest of your team. So cybersecurity is a multidisciplinary research, as you will see in my presentation. And I was made aware by Ammar that not to expect everyone to be a cybersecurity expert. So that's why I dedicated a good portion of my time to introduce these technologies and these concepts to the audience. So I'll be talking today about blockchain for trustless security. So I'll be describing what blockchain is. I won't be spending much time talking about what blockchain is. Instead, I'll be focusing on what blockchain is not, because there is a lot of misconceptions about what blockchain is. The second part of my talk will cover, or the second technology I'll be covering in my talk, is the trustless security, or the zero trust security model or paradigm, whatever you like to call it. There's a lot of discussion about what it is. So I'll also introduce what zero trust is and why it is important in today's context, and how the governments and businesses are adopting zero trust in their solutions. And then I'll talk about the application of these two technologies into critical national infrastructure. So the marriage between these two technologies, the integration of blockchain as a trustless security model for IoT, for smart critical infrastructure, is a massive challenge that has yet to be resolved. So my name is Mohammad Hammoudeh. I am a professor in cybersecurity at the Manchester Metropolitan University. And I lead the IoT, the Internet of Things Lab, and the Smart Infrastructure research team within my department. So my background, I started my PhD in wireless sensor networks, and due to my interest in distributed systems and in wireless communications, and then I slowly progressed towards cybersecurity. This was mainly motivated by my curiosity about what cybersecurity is, and it was also motivated. It was also a strategic decision, as cybersecurity is not only a hot topic in academia, but it is also a hot topic in the industry as well. And no matter what domain you're working in, no matter how good your solutions you are, if they're not secure by design, then they won't be used or adopted by anyone. So I started investigating advanced persistent threats. These are the kind of threats that are executed by or sponsored by state level or large organizations against corporates or against governments. And then I slowly progressed towards and started to focus on the security of the Internet of Things systems and cyber physical systems. And this is where I am now. And today is my talk will be covering some of the research I'm working with some industrial partners on this topic. So hopefully I'll show you a small demonstration just to give you a sense of what we're doing in real life and what type of equipment we're using and the challenges that we are facing. Please do feel free to ask me questions and stop me at any time. You might need to shout through your microphone because I can't see the Microsoft Teams as I have PowerPoint as full screen on my desktop. So if you have any questions, please, you can either leave them to the end, or you can just speak through your microphone to attract my attention. Now, so what I'll be covering today is I'll talk a little bit about what blockchain is and what blockchain is not. And then I'll briefly mention some of the use cases of blockchain. So why we're so keen on blockchain? So all blockchain, digital twins, Internet of Things, and zero trust security, all of them, they were listed as top 5 among the top 5 technological trends in 2021 in a recent report by Deloitte. So these technologies, they are trending technologies. There's a lot of work to be done, and they form part of the they will be part of the technological challenges that we'll be facing or working on for many years to come. So for the non-technical audience, I thought it will be best to describe what non-blockchain experts is to talk to them about what blockchain is not, rather than what it is, because a lot of people, they have their own idea about what blockchain is. So these misconceptions, they are being passed around, and I want to set them straight before we go into the detailed applications of blockchain. I'll also talk about the computational power that is required by blockchain. So why blockchain is not the silver bullet that could solve all of our problems in cybersecurity. And then I'll talk very briefly about what Zero Trust is and how we integrated IoT and blockchain as a trustless security model to secure critical national infrastructure. So the critical national infrastructure could be anything from the healthcare sector, the intelligent transport, the aviation, the military infrastructure, the power or electricity grid. All of these are critical infrastructures that today are becoming increasingly smart because they are being equipped with sensors, they are being connected to the internet, and they also behaving in an autonomous way with the use of artificial intelligence. So without any delay, so what is blockchain? So blockchain is always overcomplicated when we describe it. It's not as complex as people think. So blockchain is essentially a distributed is a distributed platform for storing an identical copy of a file that we call the ledger. Okay, we put an identical copy of this file on every node that is participating in the blockchain network. Okay, and there is mechanisms on how to update this file, and there are mechanisms on how to distribute updates to all nodes within the network. So the blockchain is tamper resistant. And so when we talk about tamper resistant, it means that the integrity of the data that you record in blockchain is preserved. It can't be changed easily. Well, it can, but it can't be changed easily. So all of the data that are stored inside this ledger, the ledger is essentially a database. It is a file. Think about it as a file that stores data in a specific data structure. Okay, so this tamper-resistant and timestamp database or ledger, it's distributed across a network of multiple nodes or users. So as such, it can the blockchain can validate transactions and it can update records in a synchronized, transparent, and decentralized way. And we need to differentiate between what do we mean by decentralized and what do we mean by distributed, which I'll talk about in the next slide. So blockchain is, again, it's simply a ledger or a complete record of data. And that data could be anything. I'll give examples of what that data could be. So this technology, essentially, it is designed to allow record keeping, okay, of any data. This data could be cryptocurrency, it could be information about physical assets you have, and this data has to be transferred between multiple participants. So this collection of records, it represents an unalterable, it can't be modified easily. So the key feature of blockchain is the integrity. So it provides a single version of truth. So whatever is recorded in the blockchain, we know that this data has been verified before it was recorded. So this essentially removes the need for a central authority that to reconciliate any differences or any conflicts in data among a distributed network. So we'll talk a little bit more about what this data is. So the key features of blockchain that makes it such attractive technology, everyone wants to use blockchain these days, is that number one, it cannot be corrupted. And the reason behind that is that this ledger or database that we talked about, it is distributed. There is a copy of that database, an identical copy of that database or lecture saved on each node that is participating in the network. So to add any new transaction, you need to check the validity of the data before we record it in the blockchain. So, and whenever we record any new data, we keep track, or we can trace the history of data. So if I transfer money from X to Y, then you can go back to the blockchain and you can verify, or you can see that this money was owned by X and now it is owned by Y. And this what provides blockchain with another very attractive feature, which is transparency. And there is two types of blockchains. There is the public blockchains, and these are open for anyone. Anyone can see what's going on, like in Bitcoin blockchain. And there is the permissioned blockchains. These are private blockchains. You need to have an account, and you need to have the access rights to be able to view the data. So blockchain is decentralized technology. And when we talk about decentralized, it's different from distributed. So the ledger in blockchain is distributed because we have a copy of this database stored on each node in the network. But when we say decentralized technology, decentralized means that there is no single point where decisions are made. Instead, the decisions are coordinated by nodes that are participating in the network. Whereas with distributed means that the processing or the storage is shared by multiple nodes across the network. However, the decision is still made by a centralized system that uses the complete knowledge of the entire system. And blockchain has enhanced security features. Mainly, they use cryptographic techniques that we are familiar with, like hashing, like public key cryptography, to secure the data or transactions that are being recorded within the system. They also use consensus mechanisms or protocols. So these are the mechanisms or protocols that are used by the participants of the network to decide whether the data is valid or not, to decide whether a transaction should be recorded in the network or not. And blockchain are also characterized by faster settlement. So because we don't have a centralized entity or authority, the devices, they can make decisions directly. It's like peer-to-peer network where devices, they can communicate directly with each other and reach a faster settlement. So I know I can spend hours talking about each one of these features, but due to time restrictions, I'll just go through them quickly, and hopefully I will trigger your interest and curiosity to read more about these topics. So in very simple terms, how does the blockchain works? Okay, so it's very simple. So someone has to request a transaction. So this transaction could be something, okay, transfer 1 Bitcoin from my wallet to someone else's wallet. Okay, that's a transaction. So this transaction will then be, the transaction not necessarily involves cryptocurrency. It could also involve physical assets. It could involve medical records. It could involve any other type or illegal contract or any other type of information. So the requested transaction is then broadcast to all participants in the networks. Okay, so these nodes in the network, they need to validate the transaction using consensus mechanisms. So this is a mechanism that is defined by the blockchain platform or technology. So once we verify, so that all of these nodes, they will verify the transaction. So what essentially they're doing, if I'm transferring 1 Bitcoin, for example, from A to B, then they need to verify that I own 1 Bitcoin. They need to verify that I did not doubly spend this Bitcoin. Okay, so this is the kind of verification or validation they do. So once the transaction has been validated, then the transaction is combined with other transactions to form a block. Okay, so this block of data, the reason we combine transactions together is because the process of writing a new block is very expensive. So that's why we combine or we aggregate multiple transactions in one block before we add them to the blockchain. So the new blockchain can then be added to the network, and this block will be permanent and it will be, you cannot modify it. So once it is added, it's there to stay. You cannot modify it. Well, you can, we'll talk about that, but you're not supposed, or you need to assume that you cannot modify it. Okay, so now the transaction is complete. So the first node that have recorded the block will send a copy of this block to all other nodes in the network to store a copy of it, to update their local copy of the blockchain or the ledger, and then the transaction is complete. So now let's talk about what blockchain is not, because I've already given you the impression, I've given you multiple examples about blockchain using Bitcoin. Okay, so a lot of people, they think that Bitcoin equals, or I mean blockchains, they equal Bitcoin or they equal cryptocurrencies. Okay, so, and this is not true. So blockchain is the technology that can be configured to provide many applications. One of these applications is cryptocurrency, and Bitcoin was the first blockchain platform that was designed, and it was designed for cryptocurrency applications in specific. Now, cryptocurrency is one of the many applications of blockchain technology, and the MIT, they describe blockchain as general purpose technology, or GPT. So when we say general purpose technology, it means that this technology can be applied across a wide spectrum of applications or industries, and it has the capacity for continual improvement and development. And it can act as a catalyst for innovation, as we've seen with blockchain, and now blockchain is essentially in every application around us. Okay, so the first misconception is that blockchain is cryptocurrency or blockchain, and that's incorrect. Another misconception is that blockchains is used for data storage, and again, this is very wrong. So blockchain is a distributed database for storing only reference information. So for instance, on the blockchain, excuse me, I could store your driver license or your passport number, but I don't store your photo on the passport. I don't store your date of birth. I don't store all of the other information on the blockchain. So I only provide a reference. So I could potentially only store your passport number, but I can retrieve, using your passport number, I can retrieve all of the other information from the government website, for example. Okay, and the reason for that is that blockchains, they're not designed for data storage, and I'll show you in the next slide. Data storage is very expensive in blockchains. So another example of reference data is, for example, if we're talking about insurance, it could be your policy number, but I won't include the full policy details. Okay, so this data is often expected that it won't change readily. So it's like fixed. So your passport number is just your passport number. It doesn't change. Okay, but it gives you a view of the history and also point of view of the ownership of the assets of the passport or the person who owns that passport. So blockchain is particularly valuable and suitable for low trust environments where where applications, they cannot trade directly because there is no trusted third party or intermediary that they can rely on to mediate, to connect systems together. So if you are in a world where you are talking to, where an application is communicating with other applications that it doesn't trust, then blockchain can provide a suitable platform, because because decisions are made collaboratively. They're not made by a trusted third party. And they have many advantages when compared to classical databases. However, there are trade-offs that makes the traditional databases more suited for data storage than blockchains. And another misconception is that blockchains are 100% secure. Well, the short answer, they're not. Okay, so blockchains, they use immutable data structures, and the reason they are immutable is due to the way that we use hashing and public key cryptography to secure the blocks. So the data structure we use in blockchains is blocks. There are other distributed ledger technologies like Ripple, for example. They use a different data structure. They don't use blocks. So they use databases. So it's not, so there's a difference between distributed ledger technologies and blockchain. So blockchain is one of the distributed ledger technologies, but Ripple is a distributed ledger technology, but it uses a database. It doesn't use blocks as a data structure. Okay, so these blocks are protected by cryptography, mainly by hashing, timestamps, and other public key cryptographic algorithms similar to digital signatures. So the overall security of a blockchain system, it depends on the adjacent applications, and which have been proven to be vulnerable to many attacks, and they have been breached in the past. So just to give you an example, around 6 months ago, somebody paid 2.6 million US dollars as a transaction fee for moving $130 on the Ethereum blockchain. So again, $2.6 million to move $130 from one account to another. And then a similar transaction happened a few hours later from the same address. So the likely cause of this is some sort of error or bug in the software automation, which has set a huge gas price. So the gas price in blockchain is a term that is used to refer to the transaction fee. Okay, so that's why it is very important to verify the security of the whole stack of blockchain. So you may have heard about smart contracts. Smart contracts is essentially like, if you're familiar with the service level agreement languages that they were popular when web services became popular in early 2000, they're very similar to that. It says, for instance, like if the iPhone or if the aircraft or the airplane ticket drops below $100 or euros, then buy 2 tickets. This is a smart contract. Okay, so the blockchain is not like the silver bullet that will solve all of our problems. No, it is susceptible to many different types of attacks, and the security of blockchain depends on the full stack. And I won't go through the full details of this stack, but just to highlight to you one very important type of attack, which is the network, which is the network layer of the stack. So in blockchains, usually the consensus mechanisms, they require 51 plus to approve a certain block, okay, or to approve a certain transaction, which is, so you need more than half of the network users to collude with each other, to lobby with each other in order to do some illegitimate action to change the blockchain network or to record invalid transaction. And this is extremely unlikely. However, it is doable. I'll give you an example. You may be wondering, okay, well, with blockchain, where we have literally hundreds of millions of users of nodes, how can we convince? And those users, they don't even know each other. how can we convince those people to collude with each other, to work, to collaborate with each other, to record invalid transaction in the blockchain? So what would be the benefit of such attack, and what would be the cost of such attack? Okay, so it may seem extremely unlikely. However, I'll just give you some thought I had the other day. Is a few years ago, the entire countries like Japan were cut off of the internet due to, well, they say it's an error, but we don't really know. It could be an attack. So the entire country was cut off the internet. So if we manage to cut big countries like the US, China, Iran, Japan, then the 51% attack would be possible. Okay. So another misconception about the blockchain is that they are tamper-proof, and that's not true. So as I said, the 51+ attack, it demonstrates that the blockchains, they are secure, but the attack is not impossible. However, it is largely impractical. It is very expensive to do and impractical. Just think about the idea of having to find out all of the miners in blockchain and try to get them to agree with you to reconfigure their devices to do this type of attack. So it is largely impractical, but it is doable. So to understand how blockchain provides integrity, let's look at this very quick example here. So so let's say that some adversary wants to change the data in the left. Let me see if I can put a pointer so that you see pointer option. Okay, maybe now you see. So I have two screens, so I'm looking at the bigger screen now. So let's look at a scenario where we have some adversary who wants to change the data in the leftmost block in this picture. So the adversary want to change the data that has been stored in this block of the blockchain. Okay, but if the data in this block is changed, then the hash pointer in the middle block, okay, will become invalid. So the way that blockchain work is, just very quickly, if you're not familiar with hashing, so the hashing is essentially a mathematical function that takes a file of arbitrary length. So you give it a file of any length, and it will produce a fixed size output, okay? This fixed size output, each bit in this fixed size output depends on all bits in the input file. Okay, so if you change one bit in a 1 terabyte file, then the hash of that file will change, will completely change. So whenever we create a block, okay, we take the hash of the previous block and we make it part of the next block. Okay, so if someone changes block 1, then all of the blocks that come after block 1 will become invalid. The reason is that because these blocks, each block points to the previous block. Okay, so one will need to update the block of B1. He needs also to reflect the changes he made he need to update the hash of block B1 to reflect the changes he made on the data, and then he needs to update the hash of B2 and B3 as well. So if you update the hash of B2, then block B3 becomes invalid, and so on. So it's like a ripple effect. All of the following blocks will become invalid. So one thing we need to keep in mind is that when a hash is calculated for a block, it will include all of the content of the block, including the hash of the previous block. And this is where the complexity comes from. Okay, so if we try to change one block, all of the following blocks will become invalid because each block has a hash that points to the previous block, and this gives the immunity or immutability of blockchains. And a lot of people, they think that blockchain is tamper-proof, so they are the truth machine. Anything inside the blockchain is 100% correct, and this is again misconception. So the blockchain is the blockchain's only as good as the information you put into it. So if you have a blockchain and all of the blockchains you're keeping are people's driver license, the information, driver's license information, then if you put incorrect data, blockchain does not provide any mechanism to check or to verify that the data itself is valid. All what the blockchain itself does, it ensures the integrity of the information that has been recorded by it. Okay, so it does not check whether this information is true or not. Okay. So the $1 million question is, should I use blockchain? Well, the short answer, probably not, I would say. So blockchain, it has many problems. So you need first to think about, is it the right technology for your application, or you are just simply following the trend because everyone is using blockchain, you think you have to use blockchain. There are so many issues outstanding in blockchains, like privacy. So blockchains, they provide transparency, but what you view or perceive as transparency, someone else may perceive as a privacy problem. Okay, there are many legal considerations. We don't know who owns what. It's similar to the issues we had with cloud computing at the beginning. And blockchains are very expensive. So if you want to employ a blockchain app developer, the cost starts at $5,000, and it can, for a very simple app, it can go up to $200,000. And as of May the 10th, it costs $1.68 million to store 1 gigabyte on the Ethereum blockchain. So, and to read 1 megabyte, you have to pay 3.28 as gas, we call it. So this is transaction charge. And to read 1 megabyte, it will cost you 0.03 Ethereum. So the Ethereum price is, at the moment, the Ethereum coin price is around $2,000, I think, probably a bit more. So it is very expensive, and that's why blockchain is not used as a storage platform. Now, I won't go through the details of this slide because we're running out of time, but I'll be sharing these slides so you can look at them later on and see the different use cases of blockchains. So use cases 1 to 3, they are the record keeping type of blockchain use cases. We use them for storing static information, whereas use cases 4 to 6, these are mostly for applications that they involve transactions. For instance, transferring money or transferring the ownership of a physical asset from one person to another, such as in supply chains or in the banking sector, in the finance sector. So these are the registry of tradable information. Okay, so in the first 3 applications, we store static information such as people's driver license or voting information or identity information, whereas with the second category of applications, these are mostly concerned, or they act as registry of tradable information, where the information could be part of a transaction. Right, so very quickly, a lot of people, they also wonder what on earth is cryptocurrency mining. And I've seen a very interesting article in the news recently. I saw it happened in Russia. There is a nuclear facility in Russia that has a supercomputer, and the government, they found that one of the employees is using this supercomputing for cryptocurrency mining. Of course, this is a massive security risk and massive security breach, and this gives you an example about why using blockchain could be a problem. So the most common and known consensus mechanism is the proof of work protocol, or most often referred as POW. So this is the original consensus mechanism that that the Bitcoin blockchain used. So in blockchain, this algorithm is used to confirm or to verify transactions and to produce new blocks that can be added to the chain of blocks. And this is where the name comes. We gather transaction into blocks, and then we record them in the ledger, and each block points to the previous block, and that's why they form like a chain. So the explanation of what crypto mining is here, it focuses on the proof of work as it functions in the Bitcoin network, but there is so many other different implementations of the proof of work and different consensus mechanisms. So in this case, the miners are the participants of the network. They compete against each other, okay, to complete a transaction on the network. And if they complete a transaction, then they get rewarded. Okay, they get a reward in terms of, they get, for example, on Bitcoin, they get a small amount of Bitcoin. So all of these miners, they are competing against each other to solve a mathematical puzzle. The miner or the group of miners who manage to solve this mathematical puzzle first, then they get rewarded. Okay, so the main working principles are complicated mathematical puzzles such as hash functions, integer factorization. So they give you an integer and you have to factorize it to its prime numbers. It could be, another example is the guided tour puzzle protocol, and different sorts of mathematical problems. And these are proven to be very difficult to resolve. So in this example here, we have 3 miners, and the network server will, so this is the platform, like the blockchain platform, will generate a puzzle. So each one on the network will receive a copy of that puzzle. So in this example here, we have a function. We need to find y, which is a function of x, okay? Or so the 3 users here, they will be competing usually by using some sort of brute force attack. So they try every single possibility to find y. And they will be competing against each other to identify a solution. So each one of them will submit his solutions to the network server, and the one who gets the correct answer first, he will build the block and he will write it to the network, and he gets rewarded by the network. So hopefully that gives you an idea about what blockchain or what cryptocurrency mining is. Right, so now let's look about blockchain and their integration with IoT. So as we know these days, in this slide you can see a variety of critical infrastructure applications. For instance, we can see the banking here. We can see the shipping or the transport sector. We can see the manufacturing sector. We can see the possibly the finance sector and the smart home sector. Okay, so all of these are critical infrastructure applications. Okay, and as all of us know these days, they are becoming increasingly smart due to the integration of IoT and cyber physical system devices. So, if you don't know the difference between IoT and cyber physical systems, so IoT are any device that you connect to the internet, whereas cyber physical systems are mostly, they contain not only sensors, but also actuators as well. So they can perform actions. So it could be like a robotic arm, or that can perform certain action for you. So the blockchain and IoT, they have many complementary powers. So if we think about the supply chain scenario, for instance, so we use IoT and blockchain for tracking and tracing the ownership of assets. So for instance, we can use an IoT device with GPS to track the location of a certain product or a certain object. Whereas with blockchain, we can use a blockchain to track the ownership of a physical asset. So for instance, again in the supply chain sector, if I'm shipping a container from Russia to the UK, so at this stage, I can go to the blockchain network and see that this container is owned by the shipping Russian company, and then it may be passed on to a German company. Then I can see the full trail of where this container has been and who's the current owner, how long they owned it. But with IoT devices, it can tell us the physical location of that container. It can possibly tell us the temperature inside that container. Say that I'm shipping chocolates from Russia to the UK. Then these chocolates, they need to be kept at certain temperature. So the IoT device can tell me the temperature inside these ones. Now, if we want to look at a more serious application like the one we're working on at the moment, so a lot of this information was a bit surprising for me. So on a military vessel that is equipped with certain type of missiles, when you want to launch a missile, essentially they cut off the electricity from all of the other systems inside the ship, and essentially they are focusing all of, or dedicating all of the power supply to this missile battery so that they can launch these rockets. So the power system on a ship is massively complicated, and it has so many controllers and sensors, and it has to be managed carefully. So this is a typical example of complicated cyber physical system, and the application we're working on at the moment is further complicated because we are using quantum computing devices. So we are using devices that they work with truly random numbers, and as we all know, computers, they cannot generate random numbers. However, these devices, they have a little radioactive material, the same radioactive component you have in the fire alarms in our houses. So we use the radiation from these devices to generate the random numbers, and these random numbers are stored in the blockchain as a reference data that can tell us how our data or how our assets are being used or managed. Okay, so there is an obvious integration, there's an obvious link or benefit of integrating blockchain and IoT, or even better, IoT with blockchain. This is how I see it. So why blockchain is particularly attractive in critical national infrastructure? Because nowadays, all governments around the world, they are promoting the zero trust security architecture. So this is an architecture that was created in 2010 by John Kinderberg, who used to work for Forrester Research, which is a market research company. They're not a technology company. Okay. So the concept is very simple. Don't trust anything inside or outside of your organization premises or perimeter. Instead, verify everything and authenticate everything attempting to connect before granting it access. It's a very simple philosophy, okay? Because nowadays, if I authenticate, so if I get authenticated on your university network, then you will assume that I am a trusted person, okay? So automatically, by default, I am trusted. And then I, as an insider who has been authenticated on your network, I can do so many things that could compromise the security of your network. So this zero trust or trustless theory, it's not just technology, it's about the process, it's about the mindset, the way we handle or approach security. It's about using the current technologies to enforce the idea that nothing and no one, no user, internal or external, has access until they have proven that they should be trusted. Okay, so with the current, let's have a quick look at the current security model, at the current. So in the old days, our data was centralized, was isolated. So you are a university, you have all of your resources within the university campus. However, this is not the case anymore. If you are a multinational corporate, you have an office in Russia, in Moscow, you have another office in St. Petersburg, you may have an office in Germany, you have an office in China. So how can you protect your assets? Your assets are distributed, whereas in the old days, our assets, they used to be like in one location, and then we build like a castle around it to protect it. So our resources, our networks, they do not exist in isolation, and therefore this classical defense model, it's no longer fit for purpose. Okay, so in the old model, you could associate it, for example, the moat, the watchtowers. So the moat could be like a firewall that is protecting your perimeter. Even the walls, they are like firewalls. So the soldier that is standing at the gate asking or checking people identity, this can be associated to our authentication mechanism, and so on. However, if we manage to grant somebody access to the castle and they are inside the castle, then how can we protect ourselves against this person who is inside the castle? Okay, so that's why we need to, and we have done a study ourselves. We have analyzed databases that they keep track of attacks since the 1972 up to 2018, and we identified that the number of internal actors and the number of external actors, they are roughly equal. So more than half of the attacks are initiated by internal actors. So how can we protect our critical infrastructure? How can we mitigate these threats from inward to outward, not from outward to inward, which we originally thought, or we tried to protect our systems again? So with zero trust security, we are trying to bring security closer to the assets that we want to protect. And again, this is a massive topic, but hopefully this will be something that, again, will trigger your curiosity so that you can look at it. So what are the challenges, very quickly, that we are facing these days, and how can we solve these challenges using blockchain? So when we talk about critical infrastructure, we like, for example, the power grid. Maybe in Russia is different from the UK, but in the UK, we have multiple suppliers of electricity to our houses. So it depends where you live. There is different networks or different infrastructure that is owned by different companies. So, and there is also, if you are a company or a financial institution that uses a certain blockchain platform, and I am a financial institution that uses a different blockchain platform, how can we address the interoperability issue between our technologies, not just between the hardware or the infrastructure, but also in terms of the technologies that we are trying to use to integrate or to connect these infrastructures together? So the challenge is, there is a scalability and performance challenge. How do we ensure that these systems are performing as well as expected? And how can we ensure that this massive volume of IoT devices, that our network would scale to accommodate this large number of IoT devices? Just to give you a clue on the project we're working on a single ship, we are installing 12,000 IoT devices. Just 12,000. Just think about the number. A ship, that could be, how big a ship could be? 12,000 IoT devices. So scalability is a massive, massive, massive issue. Interoperability is another big issue. So you could have the engines could be supplied by Schneider Electric, who are partner in our project, whereas you could have the missiles supplied by BA, where the radar system supplied by Boeing, and so on. So the interoperability between not only the technology, but also the infrastructure that we are trying to connect is an issue. And integration with legacy systems. So if we look at the electricity, for example, we could have, forget the electricity, even the internet infrastructure today, many big segments of the internet infrastructure still carry analog traffic these days in the UK. And this is something you would never thought it still existed in the UK. So how can we integrate it with legacy systems? How can we turn standard systems into smart ones? And how can we optimize the high performance consumption by IoT devices? And how can we protect the data, the sensitive and confidential information that are often generated from critical infrastructures. So I'll give you one example on how we use blockchain to protect or to secure critical infrastructure applications. So for instance, when we have a user, okay, let's just propose this user is an employee in the electricity company or the water company. So this employee attempts to access the corporate systems. So the blockchain can recognize that this employee, they have logged previously, okay, into the system, and it can deem them as trustworthy and grant them access, okay. But if a new contractor, say, wants to access our corporate systems, so when he starts working on the project, the first time he attempts to log in, the blockchain ledger will look at the history of this user. There is no history that we had a user who tried to log in from this particular location to these particular devices. So it will block him, or it will try to verify him, maybe using advanced attribute-based authentication mechanisms to verify his identity, and then it logs everything in the location to say that a user has been logged from this unfamiliar location, for instance. So this is I'll try to finish in 2 minutes. This is the real deal we're working on. So this is the actual testbed by Schneider Electric. So Schneider Electric built this testbed for Gibraltar, which is an English overseas territory. I'm not sure, maybe you know it. It's essentially between Spain and Morocco, if my geography is correct. So then the Gibraltar's government, they changed their mind. Then Schneider Electric, they said, you know what, we don't know what to do with this kit. We have it, so let's do something with it. And with the critical infrastructures, you need to be careful. You can't just go and test different security attacks on the critical infrastructure, because that could lead to a disaster. These are mission critical applications. So that for that reason, we have built a digital twin. So this digital twin is like, it's not a digital image of our of the physical devices, but it is a digital image, plus we can run mixed mode simulations, so virtual devices talking to physical devices to make things more realistic. So these are the quantum enabled devices that we're working with, and this is the university campus, which has 25,000 sensors in the building, and it has a hydrogen fuel cell. It's really very smart. So we connected all of these three together to be able to experiment with various security attacks to assess the security resilience of our infrastructure. So I'll skip this and go directly to show you a quick demo. Just to give you a quick feel of what we're doing. So this is an image of, so what we are doing here, we are simulating a port. Okay, this port, we have a number of floating sensor devices, a number of mobile devices, and we are simulating an intruder trying to enter to a port. So these devices, their job is to monitor the security of these, of anyone entering or leaving the port. And we try with both operational attack scenarios, like causing collision between two vessels, and we try with technical scenarios where we are performing like a sniffing attack, trying to steal data. So we see, some of these devices, they are real devices. So this data is taken from a boat moving in the sea. Okay, it represents a real boat. So we're plotting or visualizing the data from a real port. So these devices, they have radars, and we draw, we know the route that so this is the malicious boat here. So all of these devices, they have radar sensors. We can adjust the range. And so we start the simulation. You'll see this is the malicious entity, intruder, trying to gain access to our port. So what we want to see here is we want to see whether our devices whether it can evade detection, or so it's been detected, and how we can attack these devices to allow this intruder to sneak into the port without being detected. So this is a visualization of real boat that is moving around in the port, and these are real sensors that were fitted on real ships and so on. Okay, so this is just a quick idea of what we're doing. So I guess I'll stop here because just to leave time for questions. I wish we could spend literally, I'd love to spend a whole day just talking about this massive projects and about the details of these technologies. But I'll open the platform now for questions.
Thank you, Mohammad. Thank you very much for your outstanding presentation, because I understand that behind this very simple things there is a very high level of the expertise. And
especially behind the demonstration.
Behind the demonstration,
yes,
of course.
Yes.
Yes. So thank you very much from all of us, from our university, other universities, because it's very relevant today, I told you. So my question is the following. I understand, and everybody understands that for all advantages we should pay. And what about drawbacks? So I think that first of all, it will be at the level of performance of the system, which I can defend with the blockchain methods. Yes?
Yes.
And do you have some examples? Please, some your considerations on the matter of performance of the
systems. So that's a very, very important question. And so the performance is very important consideration. And the reason is for that, from a security perspective, performance is directly correlated to availability. And we know that a lot of attacks, like the denial of service attacks, are attacks on the availability of systems and data. So that's why it is critically important to understand the performance of any technologies and underlying technologies that they in turn use. For example, with the blockchain, we need to understand, for instance, not just from a cost perspective, from monetary cost, we need to understand how long does it take to generate a block. We need to understand the speed of reading and writing from a blockchain and so on. And all of these, they have to be factored in the availability of the system, because when we're talking about mission critical applications, these could be time critical applications. If we're talking about aviation, for instance, and this is one thing I don't understand, and honestly, your question is spot on, because when I'm reading particularly research articles about all of these dream uses of blockchain for 5G communications and 6G communications and tactile computing, well, the whole idea behind these emerging and future communication technologies is that they minimize the delay. So if you're telling me that you're using blockchain in order to optimize the performance of these devices, blockchain will slow you down to the Stone Age. So it's unrealistic to assume that blockchain will solve these problems. Whereas in our case, for example, so we have this very, very complicated infrastructure of that involves quantum computing, okay, and the true random numbers. And all what we're doing is we're just storing these random numbers to be accessed and used for authentication rather than for storing data.
Okay, thank you very much. And I continue my questions. Maybe they are too simple for you, but we are only youngsters in this area. From the long point of view of long-term perspective, do we have any alternatives against than blockchain? Maybe some other technologies are arising just now, or not?
So the main problem with blockchain is the consensus mechanisms. And the consensus mechanism, the power of work which we looked at, is very, very expensive, because the mining to be able to solve these mathematical puzzles.
What do you mean? I'm sorry, very, very expensive. What do you mean?
So they're expensive in terms of power consumption. They consume a lot of electricity. And this electricity has to be paid off by someone. And
the same problem of power consumption, yes?
Yes.
Just everywhere. Yes, okay.
Yeah. So now they have designed, for example, with Ethereum, with Dogecoin, and with all of these new blockchain platforms, they are using different consensus mechanisms that makes creating a new block a lot easier and without compromising on the security. So you will consume less electricity, it will take less time, less computation in order to generate a new block. So the blockchain technology as a technology will remain. So the data structure, I don't think will change, because it's honestly, it's a genius idea. But the consensus mechanisms, the protocols that are used to create the block and to record data inside the blockchain, this is the problem. And we have tens and even hundreds of new protocols that are energy efficient. So they don't consume a lot of electricity, which makes blockchain a lot more affordable and a practical solution to use. So as a technology, I think it will stay with us for a long time. But as we started to see now, there is other consensus mechanisms that are being used, which are more efficient than the proof of work.
Okay, thank you. Colleagues, more questions, because of course I have questions, but maybe we could, with you, to continue our meetings, maybe between our teams, if it's possible. Maybe later in autumn, when you prefer, because of course we have no expertise in the cybersecurity, and I understand your area of expertise, but maybe it is interesting for your team regarding our fields, our areas, and maybe sometime we can make some presentations for your team, maybe in autumn. And I do hope that Amar will help us. He is very good gate between us. Yes, maybe we could hold some more contacts and meetings. Let's discuss these things, because I'm very interesting. For instance,
one particular thing that would be interesting to share with you more and to talk to you about more is the digital twins. So digital twins is one of the it's I would imagine in a few years it will be like as hot as blockchains now. So even the UK government has a strategy for digital twins now. So it's something we can collaborate on and exchange experience with, together about the platform we've built. And this is something open source, so I can share with you comfortably.
Okay. So Yulia has a question, please.
Thank you, Konstantin Evgenievich.
Yes, Professor Gaidamar.
Mohammad, thank you for very interesting presentation and very interesting demonstration. And speaking about digital twins, as I understand, digital twins are very time dependent. They are applicable only for, they are not applicable for online application. We need time to make some calculation, make some simulation using digital twin, and after that to use these results and apply it to the real system. In what areas in your business can you use digital twins? You mentioned transport, what else?
Industry.
Hospitals, yes, power distributions in your projects and IoT in smart city.
Yeah, well, this is an excellent question. What you described, it's called a digital shadow, not a digital twin. So when we talk about digital twins, we talk about synchronous real-time communication between virtual and physical devices. Mm-hmm. So that's one of the conditions, and there is many, and we have many interesting discussions about this when we applied for our grant here, because a lot of people were confused about the difference between the two. So when we started building our digital twin, we built it as a smart city simulator. This is how it started. So essentially, you can go and plug in any part of the map. You can literally just go grab the map of Moscow from Open Maps, and throw it in the environment and start deploying sensors on the map. And then you start connecting physical sensors to the environment, and the physical sensors can start to talk to these real sensors. So, and then we added mobility. And then we, so essentially these nodes, you can refer to them, they could be, for example, an electricity charging point in the street. An electric, now with the electric vehicles becoming more popular, they can be any type of device. Now we are working on, there is a different part of the digital twin which can show you an indoor environment, which is still in early stages. It's only 2D. We can show you how indoors you can simulate for example, RFID technology. You can simulate people moving around. You can simulate rooms. You can even model the radio propagation bouncing across the walls, for instance. You can see it physically. We visualize it. So, so it's fairly flexible in terms of what applications you can use, but it's mainly, I would be comfortable now at this stage to say it's mostly for outdoor environments rather than indoor environments.
Thank you. So it's digital shadows. So
colleagues, more questions, please. I remember that Professor Hammoudeh should leave us in a few minutes because your schedule even on Friday is very intensive. So maybe we can finish today, yes? And let's think a little how we can continue. Yes. So I should understand. It's very interesting for me. Very interesting.
Email. I'm happy to any collaborations.
Maybe for you it will be also very interesting because you know that we are, all of us are from mathematics. Our areas of study lines are based on the mathematics, computer science, applied mathematics and informatics, mathematics and so on. We have a lot of students, PhDs and so on. And maybe we will find now a new point for contacts. Okay?
Yes, absolutely.
Okay. So thank you very much
for the invite. Thank you.
Thank you.
Thank you. Thank you, Professor Hammoudeh.
Thank you. Thank you so much. Yes. So
bye-bye.
Yes.
Professor, someone, excuse me,
Yes,
can
please, Amar, yes, if you was.
I forgot maybe to remind you that Professor Mohammad is a creator of big conference, I7DS, which
we know.
Yeah, this year will be in in Dubai. So I think we will try to do a workshop here in Russia. I think if Rodin University ready, we can. It will be in December, right?
Dubai.
It could be very interesting for us, very interesting for me, because I can also attract to this event my colleagues from Russian Academy of Sciences, from our colleagues from universities, founders of this seminar. A very good proposal. Thank you very much, Amar. Thank you. Thank you. So thank you.
Thank you. Thank you very much.
Thank you. Thank you once more.
Bye-bye.
And have a good,
Thank you very much.
have a nice weekend. Yes.
Bye-bye.
Yes. Thank you.